Hey guys, the final stove is done. I'm going to re-record this. I was way too long-winded. I need to just present the facts and the pictures quickly to anybody that just wants to see the process but might not want to take the month and a half it would take to build the whole thing or doesn't need all the details. So I'm going to go through this quickly, just provide the absolute minimum details or the basic facts per picture. And then for anybody that wants to build it or is really interested, I'll go into a lot more detail, kind of going over the pictures again on the back end of what you would need to know. And again, this design was created for the amateur, where there's hardly any cuts. You don't need bricklaying skills or abilities. The reason I picked this design was for somebody that wants to take a shot at this without these sorts of skills and without really a really good chimney. This thing has a chimney built in. You need a chimney, but you don't, like most of these stoves, these Russian stoves and masonry heaters, you don't need 20-foot, 25-foot insulated chimney. You already have 5 feet of chimney built in the stove, and it vents aggressively, sort of like a rocket stove. So I was thinking that in terms of the design as well. So in 25 minutes or so, when the pictures start to repeat, that's when I'll go into a lot of long-winded detail, and I'll talk about the mortar and everything you need to know, which I'm not going to do in this first segment. We'll just move through these pictures sort of quickly, like we're doing now. So this could be, I don't know how many hours it's going to be, but if you're interested in just a quick summary, it'll probably be the first 25 to 30 minutes. Then the details will be on the back end. I'm going to show you this set of pictures first. The concept behind what's called a masonry heater in the United States, or a Russian stove, is a box inside of a box. It's a firebox, usually with refractory brick, which is good to like 2,000 degrees, inside a brick box. My box inside of a box is unique. There's not a lot of, it's kind of like the elephant in a broom closet. My firebox takes up more of the general box than any other design I've ever seen. The air flows down the sides and the channels are very tight. So don't need any, if you're going to build something like this, don't need to know much now. Just these pictures just generally show you how it's a box inside of a box. And my design, again, I would say I've never seen one where the firebox is such a large percentage or portion of the total box or bell. So here I haven't even started to build up the brick around it. This is refractory brick. And again, we'll go through this step by step, piece by piece. We're still just showing you the box inside the box concept. Fire burns, there's that first roof. The flames and the smoke shoot right out at you, hit a brick wall, and then are funneled around each side and a little bit over the top, funneled down eventually towards the back of the stove, where the chimney is built in the back of the stove, inside the brick box, and that creates momentum and very good draft and draw. As you can see here, this is kind of in the front, looking in the top. The channel on the right there the channel on the left is the same. Three and a quarter to 3.5 inches. It's very tight, but it's very deep. So there's plenty. You don't get choked off, or the smoke doesn't get choked. I don't have a chimney yet. I can only tell you I found a way to determine this works. This design works. A few more images before we go step by step. The back of the stove has a little alcove, a little extra box that accommodates the chimney, the stovepipe. And as you work up, you simply pack mortar in, which insulates half of the chimney, but also secures it in place. If anybody wants to build this, you also will need mineral wool. It's insulation that does not burn. I think it's good up to almost 2,000 degrees or something ridiculous. Mineral wool. This is the first layer, the base layer. If you want to stick with me, I'm going to spend a ton of time on this and how important this layer is for anybody that's going to build these things. But for this design, you'll need pavers. In the United States, only pavers are half as wide as they are long, 8 by 4 by 2 1/4. Most bricks are not half as wide as they are long. That means it will not fit together like this and will not basket weave. This is essential. Now, fire bricks do this. Most regular bricks do not. You put two next to each other, and then you put one on top, and the one on top should match up exactly with the two next to each other, like this. Most bricks, it's a little bit off, even a 1/4 inch, which means you'll have tons of cuts, and it makes this design kind of a disaster. See, everything has to fit together perfectly in the base. There are some cuts, of course, that need to be made to put in the doors, but most layers, as you go around the outside, there are no cuts. So I factored that into the design. Again, that alcove up top, that little box up top, that's the back end where the stovepipe goes. And the stovepipe rests all the way down on the bottom. I'll show you pictures of that later. So you start your first layer by going around the outside. Again, for anybody planning on doing this or something like this that's not an absolute pro or bricklayer, I'm going to spend a ton of time on the base and how important it is when we do this again on the back end where the more detail comes. So start going around the outside. All the way around the outside is 19 bricks. If filling everything in is close to 40, but the base layer is the only layer that's going to take that many bricks. Everything else is mostly going around the outside. So the second and third layers, you keep going around the outside, layer 2, layer 3, and you're building up the middle, but while leaving an 8-inch channel open in the middle. That 8-inch channel open is exactly 1 brick. These pavers are 8 inches long by 4 inches wide. No fire bricks or refractory bricks have been laid yet, but the base here has to be perfectly level because it has to support what will be, I don't know, 500 pounds of a firebox in refractory brick. Another picture of the same thing. And no, there's no religious message. I didn't really realize it until I took pictures at a certain angle. But you'll see on the left, the bricks kind of go up and down, and on the right, they go crosswise. It doesn't matter. You're just preparing your base for the refractory fire brick, which are 9 inches by 4.5 by 2.5. Again, the stovepipe will go in that alcove at the top. Adding the next layer, I believe this is the third layer, hadn't mortared anything yet. You could even, if you had to, you could rake sand between with very little mortar. You don't need any strength or anything. It just has to be relatively secure and flat. I added half bricks up top. Those half bricks will hold the back edge of the firebox, but I wanted a channel on the left and right. I want my air channels drop down along the left and right of the stove. And it's like a little extra slide for the air. I did anything I could to create momentum because let's just say right now I don't have a 20-foot insulated chimney. A warm, long insulated chimney will suck anything. It solves all problems. Most people that talk about stoves almost never talk about the chimney. An insulated or double insulated long chimney solves all problems. It's amazing how little it's mentioned. Okay, what layer we hit? 1, 2, 3, fourth layer of red brick or paver, where in this case I'm bringing the bricks together to form the first door or the first box. I don't even have a door in there yet, but this is where the air gets sucked in. It goes in there low, and then it will go up into a grate. So you'll see, you can get away with mortaring these bricks together and smushing them together with the right mortar. Because of all the weight that was above it, again, I'm not a bricklayer. I'll show you what I did here. I didn't take any chances. I put a lintel across or a piece of metal to hold the weight because of all the weight that would be on top. But if you stagger the bricks, from what I understand, you don't need to do this. So I hadn't mortared those bricks in the last picture. You can see I pulled those 2 bricks out. You can see the piece of metal I laid and cemented across. It's unnecessary, but I didn't know. Might as well make it as secure as possible. And then I also put down the first 2 fire bricks or refractory bricks. There has to be a centimeter or 2 between those fire bricks and the firebox and the red bricks. They cannot touch. Fire bricks expand aggressively and they'll break your red bricks apart. Before we start to construct the firebox, let me just show you this image from the reverse angle where you're looking kind of down the stovepipe that doesn't exist yet towards the front. Those 2 bricks in the front that cover the door where the air comes in are not yet mortared. Just want to show you those half bricks I put at the very end. It's very important, those half bricks, because your fire bricks are stacked up on top of them. I like that little channel, that little extra channel, like a little slide that creates a little momentum for the air. And I don't know if I mentioned this, but the stovepipe, the hole of the stovepipe is at the bottom Okay, starting the construction of the firebox with the fire brick or refractory brick. It's much larger than the red brick. It's 9 by 4.5 by 2.5. Now it seems like I've got the refractory brick exactly lined up with the red brick, but it's about a 3/4 of an inch in. It's not exactly on the edge, if that makes any sense. And I added 2 little half bricks down the end just to support all that weight of this massive heavy firebox. I still need that channel to go from my air door all the way back to the bottom of the stovepipe. I wanted to be able to get back there even to clean it out with a shop vac, or you can run a fire starter all the way down that channel into your stovepipe, into the hole, and warm your chimney up. So I didn't want to have this brick right there go all the way across. I needed access to the back of the stove, so I used half bricks. I forgot I had this image, a little bit of a close-up of those half bricks, but most importantly, see, the fire bricks are not exactly on the edge. They're probably a half inch in a little bit, which gives you a little leeway, but that's your base there has to be really level, because now this is where your firebox is going to need to be constructed. Okay, building up the firebox. By the way, I made the mistake of building the firebox first and then the brick box last. They need to be done at the same time, so don't make that mistake. So here I've kind of, it was hard to do with my angle grinder. I'm not an expert with this angle grinder. Again, for those that want to do this up, all the details on the back end, created a little shelf in 4 fire bricks. As you can see that, I'll show you the close-up a little bit later. So my grate will go across there. Remember that hole in the bottom, air comes through the bottom and it'll come up through the grate that I created. Now those channels on the left and right, the air will drop down those channels. And I know it looks really, really thin and tight, and it is really thin, but overall, as the stove gets tall, the depth of the channel is extremely long, or high, I guess, even if it's not wide. So there's plenty of room for air movement. And sometimes when you have a narrow channel, it creates speed. It creates draft when you don't have a really great chimney or insulated 20-foot chimney you're dealing with. This picture is the exact same level, but now all the refractory brick is mortared together. I've chopped off the corners, the ends of the top right and the top left. You can see it's kind of chopped off around it. I mean, is that really necessary so the air can get around the corner and down into the stovepipe? No, it's not. But every little bit that creates speed, I try to incorporate because, again, right now I don't have a chimney. So, and eventually I don't know what that chimney will look like. So I tried to create as much speed as I could in the stove. Also, that thing in the middle, it's like I have a brick shoved in there to hold the refractory bricks together. They're buttered and mortared and pushed together. Again, I'm not a bricklayer. I don't know if that would stick right away. I just played it safe, and I have something supporting the weight. Quick image, a little bit out of place because I hadn't chopped the ends off those 2 top bricks yet, but I guess I was just laying in the grate. And a lot of these steel pieces I had laying around the house. A few I had to buy. I just made my own grate. This is a close-up of the groove I cut with my angle grinder in the fire brick, so the grate would not sit on top, so it would kind of blend in at the same level. Luckily, fire brick's pretty soft. Cuts pretty easily with a cheap wet saw, a tile wet saw, and it cuts pretty easily with any sort of angle grinder. Again, all that detail, I'll show you the blades to use, all the tools, all on the back end. And of course, this all needs to be mortared. Okay, here's the mortared in picture. Well, I chose to have a lot of gaps. I mean, I want air coming up. I want gigantic temperatures. Some of these grates are a little too close. If some things fall through, they fall through. So be it. It'll just fall down on brick. It can't hurt anything. Can't block anything. In my grate, I like, air on the side of letting that air flow. This shows a slice in the back of the firebox. I try to incorporate something the Russians use called a dry slot or a dry slit. It doesn't really have a proper application to this design. It's complicated, but I thought, one of the things I did adopt is Kuznetsov is a big stove designer in Russia. free flow of gases he talks about, having the gases not just channeled, but wherever they can go where they want to go, allowing them to go where they want to go. So I kind of like this, putting the slits towards the back, not at the very bottom, but probably about 4 layers up. And I'll show you another picture of this soon. So some of the gases can escape out the back and go right down very quickly into the chimney. I thought that would help my draw a bit. I think it does, but these dry slits. It's a complicated topic. I didn't think it would hurt anything. If anything, it can help. We'll talk about it later. Okay, everything is at the kind of the same level. Everything's mortared in. The grate's mortared in, and you can see how narrow those channels are between the Firebox and the pavers I used. Just under 3.5 inches. That's that's pushing it. On the back end, I'll talk about how wide your mortar joints need to be. You need to create. This is the minimum space. I mean, if I was any more narrow than this, I could work for 2 months for nothing. Okay, this picture's taken from the reverse angle. You're looking down the chimney. I don't have any stovepipe in yet. The stovepipe will probably go in pretty soon. But remember that little opening I told you about, the half bricks that you can, kind of in the middle of this picture, that opening. So again, I can take a fire starter and with a metal pole, I can slide it all the way down under the grate, through the air channel, through that little opening, right into the stovepipe. And that will help warm everything up, help warm the pipe up so it drafts properly right from the start. Now, the Russians, they wouldn't use stovepipe in the back. They would simply create a box in the back. They would use brick for the chimney. And, again, that would be fine, too, if I had a 20-foot chimney, or 10-foot over the roof. And the stovepipe, no doubt, draws much better than brick would. A quick image from the front, where it looks like we're at just 6 rows, I guess, on the fire brick. And I have bricks plugging up the square where my air enters. I don't know why those bricks are plugging it up. That just stays open. Okay, here we are. Eventually, you can get a door, but you can stay open. I mean, you can really just leave it open all the time. I put that little cap with a little pipe in just for some extra air. It's not necessary. Absolutely not. About 5 images here have to do with the door, 15 seconds each. I spent a lot more time on this on the back end for anybody interested. I got these old doors from a supplier in the Ukraine that shipped through Etsy. The doors have a little bit of a lip. I didn't like, there's the lip on the back. I used lintels and I used cross pieces because I didn't want to balance bricks on those small doors. That's just a viewing door. That is not you don't put wood in that door. I put a little viewing door in with I thought it was cool, little Soviet star or whatever. It was somebody from the Ukraine shipped. It was an old door from the Soviet Union from the 60s. This design element, a little viewing door, did not work out. I got smoke in the face, so it doesn't. I'm just going to plug it up with some insulation. It was a bad idea. In my design that I'm going to recommend on the back end will be a little bit different than this design because I learned a lot of lessons going forward. So you put your little lintels across because eventually, your lip of the door has to be, you have to encase it in brick, and brick has to then go over top of it, and then you have another, 100 pounds of brick above it. So I use little metal lintels across like that, so the brick I'm placing on top would be more secure. I had them. I figured, why not? The Russians will do, they won't use that. They'll just use the lip on the door to support the brickwork above. And the traditional way to do it, at least the way the Russians do it, is these old doors you get, they have holes, and you use wire. I drilled into the soft refractory brick, and I just wired the doors as the Russians would do to the refractory brick. And this is before you put a little mortar underneath the door, and you put bricks on either side. You'll see. You just build your bricks around the door. And this is the small. That's the larger door over the grate for the wood. And there's my first brick mortared into the side. You don't push your brick up right on the metal. You need to create, leave that 1/4 inch. You want mortar between your door and the brick. You don't want to push that brick hard up against the door. It'll squash your mortar out, and you'll have no Nothing, it won't stick, in other words. So, yeah, probably didn't make any sense, but here's all the bricks built up around the door. Going back in time a bit, probably at layer 7 of the firebox, of the fire brick, I have the first 2 bricks in the front connect up, or they're mortared together. The door where you load the wood is just below that. And I actually put a piece of metal in there. It creates like a smoke shelf, so no smoke can come back and want to get out the door where you add your wood. Okay, this is an image from a week or 2 later. Both doors are in. Maybe it's like 12 or 13 or 14 layers of red brick. I want to show you a couple things here. One, the firebox doesn't get anywhere near touching the red brick. The fire brick will expand and crack your red brick. I was too close at the bottom layers. I was just putting in a few centimeters, and I thought, I have the room. Why am I playing it so close? So I started to move the firebox out a bit. Each layer I was stuffing in mineral wool. Okay, I had to protect my door. I didn't want smoke rushing out the door. So I'll show you that in other images. I was stuffing in mineral wool, but the mineral wool was like isolating the segments. So I put this bar across. It has to do with this Russian concept, the free flow of gases, and we'll talk about it more later. The bar is hollow, and it allows, it allows the chambers the pressure of the chambers to equalize more easily. Picture from the back over the stovepipe or the chimney that's not yet in. Just showing you, I cut the corners off the back of the refractory brick or the firebox, just to let those gases go around the corner a little bit easier. I try, my technique here is to create as much speed with the smoke as possible. Now at this point, I stopped with the red brick and I continued to build the firebox, which was wrong. You want to build them up together for a few reasons. It's not the end of the world, but it caused me a few problems that I had to deal with. Here's that smoke shelf I put over the door, because there's a huge box above, and if any smoke gets pushed back down, it could want to get out the door. Probably not necessary. Also, that piece of stainless steel or metal, it's galvanized, and you want to whenever possible, you want to burn off the galvanization. You can get zinc poisoning, and galvanized metal sheets should not be exposed to high heat. The zinc turns to a gas, and it is poisonous. So there are chemical ways to remove the zinc galvanization from metal, and you can also burn it off at high temperatures, like in a burn barrel. Just an FYI. Here's another picture of what the Russians call the dry slot or the dry seam, probably at fire brick layer 4 and 5. It's 2 layers. Just technically the Russians say 3 to 4 centimeters, maybe a little bit more than that. And I have one on the other side too. The stove is completely balanced. What is on one side is exactly on the other. Just some hot gases can escape out and get into that chimney, which is, again, no stovepipe there. And that will help the draw overall, in my opinion. There's 3 or 4 images coming here of me putting the first roof on the firebox. The firebox has 2 ceilings, or 2 roofs. This is the first one. And my firebox is very tall. All my experiments allowing that fire to lap up tall, really it burns off a lot of smoke, creates a lot of heat. So the firebox is very tall in this design, by design, and there's reasons for that. So again, there's a whole nother layer that's going to be on top. This is the ceiling where the gases will pass up through that box. Now the Russians will just use 1 brick. This is much too wide than what most of them do. Again, I had to always err on the side of letting these gases flow easily. The Russians generally choke things off a little bit more because they want the hot gases to stay in the stove, because that's how your bricks heat up, and that's how all the heat radiates out. But with what I'm dealing with here, if the gases and heat and smoke doesn't move quickly or backs up, I'm screwed, and I'm not going to take that chance. So my opening is a little bit too large, and I'm allowing the gases to flow a little bit too easily. But that was just my decision. Again, the Russians, on that back piece would be just 1 full brick open for the most part. I also have a 7-inch stovepipe. I think if you're going to hook something like this up to any sort of 15-foot normal chimney, you're fine with 6-inch stovepipe. You don't need 7. Now another section is being built on top of the firebox. So there's the roof I just put in there. The gases flow up the back, but then they're going to hit another roof and be pushed forward right towards the camera. Just the next progression. It's not finished here. Gases are shooting up, and then they're going to hit that second ceiling there and be pushed hard towards the left. It's only about half done here. This picture is close to being done. The gases will be pushed towards the camera, and then they're going to be pushed, or they're going to want to flow left and right down the channels and go in that seam between the fire brick and the red brick. The red brick, of course, is going to be built up around this firebox. So this is, I guess it's pretty much done here. See, 2 roofs, 2 ceilings on the firebox. This close-up image shows it best. The back there is open. You can't really tell. But the flames, when it's really going, the flames will lap up and then hit that second ceiling, or the top of the image here, and begin pushed right towards you, towards the camera. And then there's that 3 layers of fire brick that I've kind of broken off and rounded a bit. So again, once the brick box is built up, you won't be able to see this, of course. The gases will want to lap around the sides. And if anybody's saying, well, why won't gases always want to rise? They always want to go upwards. Yes and no. They have a mind of their own. They know the quickest way out. Trust me on this. They know the quickest way out. Many real hot gases will lap up. You want to make the up and over of the gases like unattractive. I'll show you how I made that unattractive. You impede the gases going up and over, which makes the gases, it's almost like they have a mind of their own. They'll want to go around the sides and down. You want that because all those hundreds of bricks along the sides are then going to be heated up. If everything lapped over the top, you're only going to heat the bricks on the top, and then your sides would be cold. The idea behind these masonry heaters and Russian stoves is hot gases touch almost every brick. So almost every brick absorbs heat and then gives it back out over a 6, 8, or 10-hour period. Hey, look at this. Finally some stovepipe, and it looks, again, more like it should, a box inside of a box. Guys, you'll see some insulation around. That's not necessary. The darn stovepipe, every time you can get your stovepipe insulated or hot, always will draft and draw better. This stovepipe is going to be in a 350 to 400 degree stove. There's not much to insulate. I insulated around the back with mortar because those bricks on the back are cold bricks exposed to the room. I just had this ceramic stuff. I figured I might as well use it. I mean, you don't need to do this. You really don't. Okay, starting to build my red brick up to match the height of the firebox. You can see I'm still stuffing in a lot of that mineral wool. That mineral wool layer there, this insulation does not burn. Almost every insulation will burn. Be very careful. Some ceramic stuff is very expensive. The mineral wool is a little cheaper. I had to stuff that because it protects the doors below. The gases and flames are going to be flowing right kind of at us, at the camera. And if that wasn't stuffed, they could just find their way. They might want to shoot down and go through a seam in the door. So I had to keep the door protected. This image shows, again, I'm using the mineral wool in the gap between the firebox and the red brick. Remember I said they can't touch because the fire brick expands very aggressively and it'll crack your red brick. I put that hollow pipe in just so, again, the pressure would be equal on both sides. Not probably necessary at all. I've been here 20 some years. I have tools sitting. I have just all the stuff that I could use. I figured I might as well use it. Throw the damn kitchen sink at it. You don't need some of this stuff. Going back in time a bit, but this is the first piece of 7-inch stovepipe that I laid in that back alcove. I think you're fine with 6-inch stovepipe, and that's a whole lot easier to find. The standard is 6-inch for almost every wood stove. I think even Lowe's sells it. And then as I would mix extra mortar, and then when I was finished, I would just by hand with a glove just shove it down the back to hold the pipe in place. The bottom of that pipe, again, is open to collect the smoke. It comes in the bottom. And I would shove the mortar around the back to hold it in place and also insulate it because the back is cold. Those bricks are cold. So again, keeping a chimney warm is always your best bet. And the chimney in this design starts in the stove itself. Okay, just 15 seconds here, just to remind you that it's a box inside of a box, and you can see those gases will be shooting right at where the camera is, where you are, and then I'm gonna impede it so they want to go left and right down those channels, not up and over the top towards the water bottle. That's what I don't want. Now, one of the most important parts of this stove design is your final sealing of brick on your brick box has to be very tight to your stovepipe, or your smoke and stuff just going to leak out all over the house. So you have to be able to get your bricks up real tight to the stovepipe. So I had to run these lintels or these pieces of steel across. It's like gardener's fabric, this steel mesh. I think it's called gardener's fabric in the landscaping section of Home Depot or Lowe's over top. So any mortar I kind of piled in would get stuck, wouldn't just fall to the bottom of the stove. And also you mix a little dry so it can't get through those cracks, and it seals up between the brick and the stovepipe. Oh yeah, another thing that fabric, that gardener's fabric, allowed me to do. Again, it's just they sell rolls of it in any hardware store. It's easy to find. It allowed me to shove mineral wool down there tight, so that mortar would not just fall down the stove, would get stuck between the mineral wool layer and the what was holding the brick in place. Going forward a bit, I have the first sealing over the entire stove done, and I'm adding a second layer of bricks. The Russians will do 2 layers on top for a variety of different reasons. And I was happy with that first sealing because I was able to cut the bricks in such a way that the bricks got very close to the stovepipe. So I didn't have to shove too much mineral wool, and the mortar, it mixed a little dry. It filled that gap pretty nicely. Going back in time, the first ceiling or roof over the firebox and not touching the firebox, remember, cannot touch because of expansion issues, use these angle irons. I think some people call these lintels as well, but they're an angle or shaped like an L, and that L is not just to hold the brick. That angle creates tremendous strength. You can get these lintels where it's just a flat piece of steel. They tend to sag. They're not nearly as strong. Now, some stove makers will insulate these pieces of steel. I don't think it's necessary. I mean, your temperatures are, again, they're flowing towards the front there. There's pieces of steel laying in there. I'll show you a close-up of that. Yeah, maybe it is going to be 500 or 600 degrees once the smoke gets up there. But the steel's good to 2,500 degrees. Maybe it sags a quarter of a millimeter over 10 years. I mean, so what? Nothing's going to happen. You don't need to insulate your lintels. Again, going back in time just a bit. Again, this is the first row for the first ceiling, which is about 3 inches higher than the firebox. 1 angle iron is used. The right side of these bricks is just resting on the back edge of the stove, so that supports the back edge of the bricks. And I was able to get everything pretty close. So as I just shoved mortar by hand, it would hit that gardener's mesh and the mineral wool, and it created a nice, even at the first ceiling, created a nice tight seam around the chimney. And the chimney, smoke's not going to be pouring up there anyway, because remember, in this stove design, the smoke is drawn low. So, but you shouldn't have any gaps, of course. If there are any little micro cracks, again, you have another layer of sealing that's coming that's going to fill it in again. One last thing about working with angle irons, you buy them, they're too long. They're not going to stick out the side. The best way to cut these is with a Zoll saw or a reciprocating saw and a metal blade. I was actually surprised how easy it was. I thought it would be an absolute nightmare. I tried the angle grinder with a metal cutting blade, and they're expensive. You have to be real careful too. 2 sets of eye protection, steel flying up in my face. The angle grinder did not like that at all. Much better with the, borrow somebody's Zoll saw or reciprocating saw. Get a steel blade, and you go along one level, then you go along the other. Just about 30 seconds, you get right through it. Oh, one other thing here, I cut them a little short. I didn't need a ton of strength. I'm not bridging the huge gap. So you don't want to cut it and take your steel all the way to the end where it could be seen. So I cut it an inch short. That way you can just mash mortar in there with your fingers or whatever, or just butter it and just put the brick on top so you don't see any steel. But you don't want to put it right on the inside edge either. Then you'll sacrifice strength. This part was the hardest decision I had to make. What you're looking at, the stove door is to the left. The two pieces of sheet metal are laying on top of the firebox. The first row of my ceiling via the angle irons is in. The stovepipe is to the right. So what I'm trying to do with these pieces of sheet metal is make the hot gases and the smoke not want to flow up and over the top and down. I need them to go around the sides to heat the brick in the side channels. Now I only have about 3 inches between the top of the firebox and the ceiling of red brick going over top. But that's enough where the real hot gases would want to flow up. If I didn't do this, I'm impeding the gases from coming up. I extend the ceiling out a bit with this sheet metal, which makes, you can see it better in this image, it just makes it to flow up and back and down. It's an extra 1.5 feet. It has a mind of its own. Someone said, well, hot gases always want to go up. No, they don't. No, they don't. It will know the quickest way out somehow. I don't know how. It just does. So I always will. You're going to get some super hot gases going up. The top of these stoves always gets hot. You can't avoid that. I need to err on the side of impeding it a little bit too much. So it's gonna just want to flow side to side and then down. And I think I got this right. Oh, I forgot. I did not mortar these pieces of sheet metal. I didn't mortar the bricks. In fact, I like the bricks in the back because it's another hindrance. If any gases escape over the top, they might hit those bricks and again be pushed to the left and to the right down the channels. These bricks are heavy. These pavers are heavy. They're not going anywhere. I didn't need to use any cement or anything like that. Here the stove is almost done. I just have one layer of sealing. I need to put that second layer of sealing. The angle irons are supporting only that one layer. So for the second layer, you'll see I did it completely differently because I kind of I'm not a bricklayer, so the top of my stove was a little shorter, say, than the base. So I don't want to have to make all these cuts again. So you just put in these, quote, design elements to make your life easy. And then you say, oh, I meant to do that. And I think it looks cool. I just spaced these bricks out so I didn't have to I have some halves in there, but I had those halves. I didn't have to make any cuts. And when you have wide joints, it's easy just to fill in the huge seams with mortar. And I like the way it looked, the way it came out. I didn't want to make all these cuts because I didn't have any room up top. You can't tell by looking at it, but I'm no bricklayer. The top of the stove's a 1/2 inch shorter than the base. I don't know how that happened, but so I just say, oh, you like my design element? I meant to do that. When it's just because I'm so damn tired of working this stove lazy, I don't want to make no more cuts, but it worked out. I think it looks pretty cool. Just a couple more images in this first section as a reminder as I worked the red bricks up and I added my stovepipe. Any extra mortar, just shoved it in the seam. Again, I used a 7-inch stovepipe. I think you're fine with 6 if you're hooking it up to a real chimney. 6-inch creates a lot of gap, a lot of room, which is good because, the whole rocket stove principle, the more you can insulate the chimney and keep it super heated, super hot, the better your draft and draw is going to be. And again, this is a poor man's rebarb. When I was finished, I just would shove in nails. That way, a day or 2 or 3 later, when I'm putting the new mortar on top of mortar that's already set up, it has something to adhere to. It has something to hold on to. So, because, each layer of a few inches of mortar was done per each layer of brick. You just throw a few nails in and it kind of binds one level of mortar to the next. Again, probably overkill, not necessary. The insulation, not necessary. Just, it's better to wrap the damn thing with it. You put some wire around it. By the way, don't touch this ceramic insulation. It's nasty stuff. Don't breathe it either. But I figure, why not just, it's better than throwing it out. This is the bottom of the stovepipe. It just sits right down on the base. No connectors, no nothing. all the cement around back holds it in place. So I used a 7-inch stovepipe, and I added a little bit to it. You can see the outline where I drew in white. I add that little V up the top. I don't know why. I think that just creates a little bit extra draft. Again, I had to always err on the side of getting the smoke moving as quickly as possible. If it moves, somebody was, well, if it moves too quickly, all your heat gets out too quickly, and it doesn't heat up your bricks the way it should. I hear you. You know, I'm going to overcome that by ridiculous temperatures in the firebox. You're right. If it moves out too quickly, then I'm losing a lot of heat. I mean, the Russians, you know, they pride themselves that balance of having all the energy go into the stove, and what goes up the stovepipe is only between 120 degrees Celsius, not Fahrenheit, and 150, 120 to 150 Celsius. You flirt with 120 and below, you don't have the energy to go up the chimney. You smoke yourself out. So, you know, what's going up the chimney for me, if I can ever get this permanently hooked up to a real chimney, might be 200 degrees Celsius or 180. And I'm, you know, yeah, I'm letting a lot of heat go, but I'm no way I'm going to play it close. So I have to add a few extra logs or burn. I mean, you know, in this situation, especially with the design that was untested, now I know this works. You know, it might move too quickly. The gases may move too quickly. It'll heat up. Again, big deal. A few extra logs. Better than working for 2 months for nothing and smoking yourself out your own house. One other thing that's nice about this design is, remember that channel that starts where the air comes in under the grate and you have that direct line all the way to the back of the stovepipe? I can slide a fire starter, like these gel packets, via just, you know, using a big piece of rebar or something. You know, I'm going to make something a little bit more permanent. Can slide it all the way so your fire starter goes right into the opening, and your pipe starts to heat up via the gel pack or whatever fire starter, and you have access. Also, you could you know, you could put a shop vac with extensions all the way back and clean it out. And one other quick thing, if anybody's saying, well, the whole bottom is open? No. When it burns, it should not be. I'd like to see what happens when it's completely open, but no, I just cut a square of mineral wool and pushed that square, and it was pretty tight, so there was no exchange of air between. The air would come in and go right up, you know, through the grate into the wood. If it was completely open, a lot of the air would just go directly back to the chimney, which could create ridiculous draft. But I'm going to try, you know, maybe I'll try it sometime. But I figure the way around that is it's kind of a pain in the neck. You know, you have to slide a big square of mineral wool back all the way back. That's tight. But you know, you don't have to take it out every year or so to do your clean out. Well, you would have to take it out to do that initial, you know, to get that fire starter back in the pipe. Then you put it, but you're supposed to, the way these stoves are supposed to work, once you heat everything up, you don't have to, you know, you burn it twice a day for weeks at a time, and everything stays kind of warm. You don't have to, you know, do that fire starter, that heat up trick. Only initially you need to do that. One more comment about design while we're on this image. There's some European counterflow masonry heaters that actually, it bows out a little bit. So, you know, the gases, it's only 3 inches and a quarter, but then in the middle of the channel, you know, you'd have to almost bow the bricks out or curve the bricks a bit, and then they kind of tighten up towards the end. I don't know if that creates draft, but, you know, it can be straight, of course. I mean, to bow it out it's kind of, you know, I kind of did that by mistake because I'm not a bricklayer. It only bows out a 1/4 inch, and you can't really tell overall. It looks square because there's so many different types of bricks that I used, and so many different. Some bricks are burnt. You can't, you know, some bricks are cracked. It covers up all my mistakes. But if anybody was creative, you'd almost bow that center of the channel out a 1/2 inch, and that could create some additional draft as well. But what you don't want to do is if that center of the channel was in a little bit, ooh, that really would create a problem. So your gases flow around the corner. They have 3 inches and a quarter to work with, but then they have the whole 4-foot drop to work with. But then as they go back towards the stovepipe, as you lay them, you came in a bit, you made a mistake, so then you came in to just 3 inches or just 2 point something, and it choked off there in the middle, that would be a disaster. So you have to make sure your channels you have that consistent. It's better to do larger mortar joints. I'll talk about that in a segment in another video or a little bit later here, where you really want 3.5 inches on each side. I really played it close, and it worked out. But you don't want gigantic channels. Someone's like, well, I'll just add an extra brick. You don't want gigantic channels. Once you have gigantic channels, everything starts to slow down. And again, if you have a 20-foot insulated chimney through the center of your house, it'll pull anything through. It's not going to matter. But these people make these rocket stoves, and they just put a pipe up into this huge area. And again, if you just one little 3 or 4 foot pipe up, and the volume of air, the box that surrounds it is huge, and it's fine. If you, again, a long insulated warm chimney will pull anything through. But if you're not dealing with that, and your chimney's kind of a bullcrap rig up or something, 15 feet along the side of the house that gets cold, and you need to keep these gases moving quickly. And I think that's what I was able to successfully do here. This design, you need a real chimney for 98% of any Russian stove or masonry heaters. Most Russian stoves, it's a whole nother section on top of what I did. It's a bell on top of a bell. So you have a big enough chimney, again, anything will work. But this can be used, I believe, by somebody that I don't know. I can't tell you, not to have a perfect chimney that's inspected by your township. I certainly would never tell you to do your own thing. But this will work more than other designs. That's why I wanted to test it, and that's why I did it. About, I don't know what it was, like 8 years ago or a little bit more, I didn't make one of the first rocket stove videos, but that first wave of the rocket stove craze, I had a video that got 200,000 views or something like that. It was one of the first. There's thousands and thousands now. One of the first 100 or so that a lot of people saw. So I've been doing this whole stove thing, rocket stove thing, for a long time. The main lesson that was learned from the whole rocket stove thing was how important an insulated hot chimney is. So again, for this design, what's nice about it, if you don't have this huge, perfect chimney, 20-some feet insulated going through the middle of your house, because that stays warm, versus outside, you're getting the first 5 feet of chimney in the stove, and it's warming itself up because it's in the stove. But I didn't go the whole way. I mean, I was, if you could, I was gonna say, why not? Why not? I was gonna say, why not just insulate? Like you saw, I wrapped that one section in ceramic, and again, you have to mortar it in so the stovepipe stays secure. But if I was using a 6-inch stovepipe and I had a lot more room between the brick and the stovepipe, I probably would go for the full like rocket insulation effect, because then you get no smoke. Meaning I would probably use like that gardener's fabric, that metal mesh all the way down, and then I would use like 5 parts perlite or 5 parts vermiculite to 1 part, say, type N mortar, or like 1 part sand, 1 part type N, 5 parts perlite or vermiculite. And you just, like the rocket stove makers make their riser, you make this whole thing like a rocket stove riser, where it's insulated in the front and the back, and then the draft gets ridiculous, and all the smoke gets burned up. I really couldn't do that because I was using a 7-inch pipe, and there's some reasons I wanted to just allow a little extra space. I don't think it's necessary. If you had the 6-inch, you got tons of room in this little alcove, and you find a way, you kind of screw your mesh into your mortar joints as they're a little soft. You could, if you wrap the whole thing in mesh, or you put a little piece of styrofoam across where the smoke enters at the bottom, then as you pack your mortar in, or your mixture of mortar and perlite. Perlite is an insulator that it doesn't burn. Or vermiculite, you could, pull out your styrofoam, so you have your entrance way for the smoke at the bottom of the chimney intact, but then you're insulating the whole thing up. That would be kind of sick. But it's not going to make that much of a difference because, like I said, and I hear you, the damn pipe is inside of a 400-degree stove. So what's there to really insulate? Just really the back. And again, I erred on the side of I didn't use the perlite and the vermiculite, the insulation on the back. I just used mortar, which will insulate in and of itself, but not as well as some of those other materials. I just wanted to make sure my pipe was just rock solid in without any movement, for a few different reasons. Different connectors up top, and I was, putting some weight on it, and it needed to be super secure. Your 5 parts perlite to 1 part type N or type S mortar cement is going to be secure, but it's not going to be as secure. You don't want to bump or fall into the damn stovepipe. It could crack a bit, but so I didn't insulate it. Some people might want to go the whole way and see if, this thing creates draft. I don't think you need any more draft, but I don't know. Some people might want to do that if you build something like this. A few minutes on the base, because for any of these types of stoves, it's so extremely important to get this perfect. Again, this is why you need bricks that basket weave, where the width is exactly half of the length. And even if it says, put 6 or 7 or 8 bricks down, guys. Sometimes the manufacturers, it's a little all over the place, and they're not all the same quality. Pull 7 or 8 or 10 and line them up and make sure they basket weave. Make sure the precision of the manufacturer is exact. That's key. If it's off even a 1/4 inch here or there, it's a disaster. So that's why, again, I had to use pavers, which I think these pavers are more shale than clay. I'd much rather have clay, which is softer. There's definitely clay in these, but it was very difficult to cut with a wet saw. I probably picked the hardest paver in the world, much easier to cut through the fire brick and the refractory brick. But there are some pavers that are, a little softer, a little easier to cut. Anyway, just regular brick won't basket weave. Remember, 2 next to each other, 1 on top, has to be exact, or don't do it. Now, when you lay your base, it's 19 bricks around the outside, filling everything in. It does fit in perfectly, as you see here, because everything fits together in basket weaves. It's close to, I think it's around 40 bricks, which is a lot. But again, this is the only layer other than the ceiling of the roof where everything has to be filled in. Now, here's the thing, guys. You watch these Russians do this. They do it every day. It looks so easy. It's just laying the base down on cement. If you're going to, by the way, guys, these, I don't know, 3,500 pounds for everything. So if it's anywhere other than a slab or in the basement, you need to reinforce underneath. That's on you. I'm on a slab down here in the basement. So I would err on the side. Here's the thing. For this design, you need width. You need the joints when you press the bricks together on the same level. The joints have to be pretty thick, not 3/8 is normal, like a 1/2 inch. You need to create width. You need that. You can't go less than 3 inches on each side via the channel. But it's a disaster. It's extremely difficult if you want to use big mortar joints, brick on top of brick. And say, well, that would look ridiculous, right? You're pressing the bricks together. You want a big mortar joint, but on top, there's almost no mortar joint. Yeah, I don't know how that would look, honestly. You could use a red dye in the mortar so everything kind of blends together, depending what brick you use. I don't know, guys. I'm just saying, if you want to cut a month off, and again, I'm making this video for an amateur, of course, somebody that never done anything like this. That's why I'm doing this. I'm not doing this for people that are experts or bricklayers or stove makers. So to make it as easy as possible on yourself, you want to use extremely thin joints for the bricks on top of each other. So if you see, I used all these different types of bricks, all different sizes. So I had to butter 1/2 inch, 1 inch of mortar. And then I had to use my level this way, level that way. Oh, tap this end. Oh, tap that end. Oh, it's a little off. Tap, tap, tap. Every brick was slow, and some bricks were small. Some bricks, this is what I did, and it ended up great. And but it was over 2 months. If you want to do this in 2 or 3 weeks, you want to push your bricks down right on top of each other so you can maintain your level very easily. But you have to create width. When the bricks are at the same level and you push them next to each other, you have to have width and length. And again, if you're worried about the looks on that, I don't know what that would look like. Wide joints next to each other, almost no joint, brick on top of brick. There's no other way to do it. You could do it like me and have gigantic mortar joints everywhere, which, unless you're a bricklayer, takes forever. And putting a level on every brick 6 or 7 times, tapping back and front, left and right, tap, 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 check it again, tap, tap. Okay. If you don't want to do that, you just smush, basically, when they're on top, you just smush them down with a level. Your joints are like a 1/4 inch, nothing less. You don't need a joint. You need a little bit just to hold it. So that's what I would do if I had to do all over again. I don't, if it looked funny, if you use it like a lime, it's good, very white, your joints are very white, it could look kind of stupid. But if you have a red paver, and my bricks are black and brown, and because I have all these tests where I smoked them out and they got black, and it's just, if you buy new pavers, sometimes they'll look consistent. You could buy a red dye that goes into the mortar mix, and you don't really see the joints. It all looks like one. I don't know. I don't think the looks are as important. Again, you could spend an extra month doing it and have huge joints and everything. But you have to create that width. If everything's smushed together, by the time you put your if you smush on the same level, if you smush the bricks together and your joints are very tight, once you put your Firebox in, you don't have the room on the channels. You'll only have 2 inches, 2 3/4 inches. I don't think that's enough. So you'd say, well, again, I'll just add another brick across the front. You could do that. Then, I don't know how many bricks I pushed here, red bricks, 320, something like that. You could do that, but then you're pushing 360, 380 bricks with the channels down the sides being very wide. As long as you have a huge 20-foot insulated chimney, it'll pull anything through. You're not going to have an issue. But I don't like that. And the stove gets massive if you do that as well. You could do that, and you don't have to worry about joints or whatever. Just add an extra brick across. This is, per the design here, you see it's 3 bricks across right at the bottom, the front where the stove door is. 3 bricks and then 2 down the side, which is the same as 4 bricks across. So your next layer would be 4 bricks across. The layer after that would be 3 bricks, 2 down the side. Always staggered, of course. So my joints, I played it too close. I mean, I was 3/8 or so, and I had to start to make cuts, honestly. So some of my joints are larger because I painted myself into a corner so badly, I ran out of room in several areas, and I had to make cuts, which was, you don't have to do this if you plan it out properly. If you make your joints for the bricks that are next to each other large, you'll always have that room. I screwed myself and it cost me, but it's no fun having to cut 60 bricks or whatever. But it was not the end of the world with my wet saw, but it's not fun. This design is set up so, you don't have to make like 15 cuts for the whole stove. Not much. So that's my recommendation. Do not go tight as the bricks are next to each other unless you add an extra brick, and the ramifications of that's on you. I don't know what that will do. So if you're not an expert at this, how do you even do the base? Well, you lay it out without any mortar with good sized joints. You just lay it out and you space it out the best you can. Maybe you create a spacer. It's not easy. And no mortar, you lay it out. Maybe you use some tape or a laser level. And then what you do is you just keep checking corner to corner with a tape measure. And the first time I checked it, I don't know, 38 inches or whatever it is, and another one was 37 and a quarter. It was totally off by 3/4. Well, how do I make up for that? Where did I go wrong? You just, as an amateur, this is just what you have to do. The experts will know how to just deal with this. I don't, you don't. This is for an amateur. Total top left corner to bottom right with a tape measure. Total top, the alcove where the stovepipe is, top right to bottom left with a tape measure. Has to be exact. The X's have to be exact. Not the alcove, but that outer corner, top right, bottom left. Left corner, top. Okay, once you get it exact and your joints, your spacing is correct throughout, because you're creating space with your joints, you're going to have space with every single, no brick is ever going to touch any other brick in your base. So, okay, you could pick them up one by one, butter them, put them down. I did not put any mortar on between the bricks and the slab of my basement. I figured there's 3,000 pounds pushing down. Like, where's it going to go? When I had everything down and everything was measured, and I used my square, and I thought everything was as perfect as I'm going to get it, I mixed up some real soupy type N cement. I like type N is more lime. It's softer than type S that has more Portland cement. Very soupy, almost like poured it in the cracks. Just a 1/4 inch, a 1/2 inch. You don't fill it up or anything. I didn't want to go all the way to the top. I didn't want to move my bricks. Didn't want to touch anything because the base was perfect. So you put it in a cup almost, real soupy. But then you come back the next day and just regular type N mortar, no sand added, soupy. It's going to set up. It's going to be hard. So that little 1/4 inch or 1/2 inch along the bottom, it's going to hold everything in place. Then you just come with you could even use a grout float for tile and you could almost just brush sand in. You could, then whatever, you just rake your drier mortar mix across the top and everything's secure by what you pour it in. That's the only way I could figure out to do it, not being an expert at any of this. Again, the Russians just put them down one by one. Everything's perfect. They do it all day. They do it for 20 years. It may make it look easy. It's not. This base is hard to do. Very, very difficult. But put the time in here. And again, once you get everything, if you make that type N soupy, you can just pour it in. If it's dry, you're not going to get it down in the joints. Make it soupy. It'll harden up. It'll harden enough. So then, you have plenty of cracks that's left when you put your real solid mortar in, or you could even, push it in, trowel in, you smash it in by hand, whatever you want to do. It doesn't have to look pretty. Nobody's going to see it. And that'll hold everything together. That's my best advice on the base. Don't whip it out for an hour. Just take 3 hours. A 2-step process. You'll be glad you did. Everything depends on this base. Okay, guys, let's talk about pretty much the most important thing, mortar, and the difference between mortaring the Firebox, which is here, and the red brick. I made gigantic mistakes with the Firebox. I had to do what I had to do with the red brick because I used all different types of red brick, which means you have to butter everything and use a lot of mortar and huge joints. But for fire brick, it did cost me a lot of time and effort, and now I know what to do, so I'll share that with you, and hopefully, you could build this Firebox up pretty quickly and easily. Keep your joints as small as humanly possible. So, and also, the key to this fire brick is you get again 9 inches by 4.5 by 2.5. The brick stores sell this thin fire brick that some wood stoves take. You want the real big, thick brick, 9 inches by 4.5 by 2.5. Again, it's not, one isn't more common than the other, but if you ask for fire brick or order fire brick, you might get the thin briquettes. You don't want that. So it's extremely porous, which means you don't just have to wet it. You have to drop it in a bucket of water. All right? This is essential. This cost me dearly. A few spray bottles, that's enough. No, it's not. Spray, put on, and then it just comes right off. No, you have to drop it in a bucket of water for 30 seconds to a minute. Then if you're going to use you can use refractory mortar, which is good to 2,000 degrees, or you can use 3 parts, like a lot of the Russians and traditional stove makers will use 3 parts sand to 1 part clay. I probably would add a little lime and type N if I was doing that. If the joints are so thin, you probably could use regular mortar. I don't know, but I can't recommend that for the Firebox. So if you use refractory mortar, it's expensive. It's like, it's like $40 a bag or $45 a bag. What you want to do is that brick should be soaking wet. You put it super thin on, you butter it super, super thin, almost like you butter then scrape it off. I've seen this done by the Russians. You create a layer it's almost like it's thinner than pouring syrup on pancakes. Then 30 seconds later, you add another layer on top, just a quarter inch, little tiny bit, and you do the same with the other brick. You wet, completely sopping wet, a layer that's super thin, like 1/60 of an inch, and you scrape it off. Then 30 seconds later, I know it sounds strange, you add another little layer, and then you absolutely smush them down on top of each other. Where they say you want quarter inch, no, you want it smushed down. Okay, maybe you want a quarter inch, because if you're off a little bit down the end, you can hammer it down. You want a rubber mallet. You push down with your level. You hammer it down with your rubber mallet, and basically it ends up almost with one brick just laying on top of the other brick. If you get 2 or 3 or 4 level, you can just continue to work off that level and build a Firebox pretty easily. Like a dope, my joints are over a half inch or a half inch, and I'm using levels, and I've got to hammer tap this end and tap that end, and then it's setting up like super quick because I didn't realize the darn things are so porous. It just sucks the moisture out of the mortar. The mortar's like setting up in a minute. It's getting hard. Like, what the hell is this? Had to redo whole rows of bricks. So don't do what I did. If you use just sand and clay, there's no hardening element, so you don't, there's no rush to work. You still want to soak your bricks and get them wet. It still will suck all the moisture out of your sand and clay, but I would still add probably some lime and a little bit of type N to your 3 parts sand to 1 part clay. But you have more time to work with it, and I would still, smash it down and use a rubber mallet. So once you do, a row or two, you just get good at it, pushing your full-size level down and pushing everything down. And if your 2 bricks to your left are completely level, then you just have to match up with that. You don't have to check each brick on its own. So the way of mortaring these refractory bricks is completely different than your red bricks, which could vary depending on what type of red bricks you get. We'll talk about that now. Okay, for the red bricks that surround the Firebox, a lot of traditional Russian stove makers and many people in the United States, they'll use 3 parts sand to 1 part clay. Or this fire clay was probably like $6 20 years ago. Now, of course, it's $40 or whatever, and it can even be more than that in certain places because everybody's got to have their fire clay sink, so the price shot up. It's just everything's a nightmare anymore in terms of inflation. Sorry, I need to just stick to the stove conversation here. So, if you buy the fire clay, buy your masonry sand at Home Depot or whatever. It's very fine. Not the play. Don't buy the play sand. You can use the play sand, but the masonry sand, it's pretty easy to get. 3 parts sand to 1 part clay. I don't like that though. Okay, I don't, because it doesn't set up. It never gets real hard or strong. It's great if you want to break your bricks down in a year. You can just scrape the mortar right off. But if you want to do 3 or 4 rows in a day or 5 rows, it just doesn't. To me, it just doesn't set up. The bricks will slide around, and so I liked adding to my 3 part sand, 1 part clay, a full half a part of lime. Home Depot and Lowe's, the home centers still sell just the big 40-pound bags of your old-fashioned lime mortar. It's white. It's a little toxic. You don't want to breathe it. It's caustic. And I also added just maybe a half part of type N cement or mortar. So mine was 3 parts sand, 1 part clay, half a part of lime, a little dash of type N or a half a part of N. Now, if I want to break this down, I can still scrape that off the bricks. It's not going to set up with all that sand and clay and not that much mortar. Lime doesn't get that. Lime is soft anyway. I'll be able to scrape it off and save my bricks. But what it does is in just 5 to 10 minutes, it gets real sticky. Even if you tap it or bump it, it doesn't want to move. Especially if you have a porous brick, like my pavers were very porous. So you can come along 15 or 20 minutes later and do another row without worrying like the row below is going to slide. So one of the keys with that, though, is the porousness of your brick. If you have a porous brick, it has to be extremely wet or submerged for 30 seconds. I didn't submerge them. My paver was very porous. I just used the spray bottle like crazy. Now you know it's porous. You just drop it. You get your brick. You drop it in a bucket. It starts bubbling, and then it's real porous. That's fine. That's okay. A brick like that might absorb heat quicker. But you have to keep them very, very wet. Can't just throw mortar on top. It'll suck all the moisture out of it. It'll be a disaster. But I didn't submerge my red bricks, even though I guess I could have dipped them. That would have been easier. Lots of pumps of the spray bottle. And get yourself a high quality spray bottle at a good hardware store, not the cheap stuff from the dollar store. That's a disaster. So it's better to have a full Home Depot bucket of water. Dip it, 10 seconds, pull it out, and butter it. I liked, for the most part, buttering one brick at a time. But again, that's because, remember, I had to use all this mortar in these huge, thick joints. I recommend that, see all those joints going across? For your stove, if you do this and you're an amateur, I would have basically, just like the fire brick, one almost on top of each other. I'd butter it very, very thinly, and I would press hard. So it's almost one brick on top of another. Not too hard. You want a little bit of mortar, of course, because that keeps the smoke and from getting into your house. But I'd press it pretty hard down. Not as hard as the fire brick. Because that you almost want one brick on top of each other. But it just makes it so much easier than once you have these big joints. It's just trust me, it's a nightmare. But you want your thick 1/2 inch at least joints where, say, that top row, where they're pressed against each other or the ends are touching the end. That's where you need your 1/2 inch or a little more, because you need width or the whole design doesn't work. Again, I don't know how that would look, or you could always use dye. If you have your bright red pavers or bright red brick that basket weaves, you could use a bright red dye, or it'd all blend together. I don't know. I like the look of mine. It's not about looks, but I had these old brick and I had different types of pavers. I use primarily one type of paver. That's the paver that's on top. I use this local McAvee 8x4-inch paver that's made right over here in Phoenixville, Pennsylvania. That's what's on top. It's black because I used it in a bunch of experiments outside. It got smoked, and I like that look. It's the black. I didn't like. That's not design or anything. It's all black because I used it in so many experiments, like out in my garage and stuff. It's black from smoke, and it has this old look to it, and it worked. So, but again, you could build this stove pretty quickly if your joints, both in the Firebox and in the red brick, is very, very thin. You just keep tapping down, pushing, full-size level, 3-foot level, metal level, pushing down. And, again, one last time, your joints are thick end to end, and I don't know what that would look like, but you need the width unless you add, here it's 3 bricks across in the middle, 1 down the side, 1 down the side. So it's down 1 left, it's 4 bricks across, 3 bricks down the side, 4 bricks across. You could go 5 bricks across or 4 across, 1 down the side, 1 down the side. Your channels on either side then are going to be, 4.5 inches, 5 inches wide. That's huge channels. Again, if your chimney's 25-foot chimney, it'll pull to anything. You'll be fine. But it creates a gigantic stove with tons of bricks. Enough said on that. Let me mention this important part. One of the keys to this design is your Firebox is thin. And it's tall but thin, so you can just have 2 fire bricks pushed up against each other to create the ceilings. Other than that, you have to, you kind of really have to know what you're doing, be a Russian stove maker, or push lintels or angle irons. Here you just, it's thin enough where you can just push 2 together at both ceilings to create your ceilings, okay, without any lintels, without any supports at all. Now, I didn't trust my refractory mortar for a lot of reasons. I don't think every time I've worked with a refractory mortar, it's not real strong for some reason. Again, if you just have these huge fire bricks laying on top of each other, you can almost lay them on top of each other without any mortar. And that's not good because some air will come and go and your firebox won't be as hot. But you don't need it to be strong. But when you make your ceiling, especially on top, and you push them together, it does need to be strong. Now, one thing, this is very important, one thing you can do, what I did was you get your angle grinder, and it was an angle grinder that takes a 4 or a 4.5 inch wheel. And you can get a masonry cutting or a brick cutting wheel, and there's actually one, I forget what it's called, but you can use a 4.5 or 4 inch wheel it's a grout remover or a mortar joint remover in an old brick building. It's very thick. That's what would be good. What you do is, when I created that ceiling of the fire bricks, of course, both ends are buttered with your mortar. We'll talk about mortar again in a second. And you push them together and they stick. Well, most good mortar will stick. You don't have to do what I'm going to suggest. But I cut a channel, like a river, down lengthwise. So you see, like up top there, I push these two. They're mortared underneath. Half is sticking out, making the ceiling, and the other half is still resting on fire brick underneath. So it's mortared underneath. That's going to hold on its own. But of course, your end to end, when you push them together, both are mortared. I didn't trust my mortar, so I created a 1/2 inch channel or river, like, I don't know how to describe it, like the Grand Canyon, but just the length of my blade on my angle grinder. And then when you smush them together, the mortar then kind of goes a 1/2 inch into each brick, and it kind of creates a link or a latch. You see, I'm not sure if I'm talking about. I don't know how to talk about this, but I mean, I didn't trust my refractory mortar. So I added some lime, and I added some type N mortar to my refractory for when I was pushing them together. I didn't trust it to get real hard and have strength to hold. Now, for some reason, when I added the refractory, the lime and the type N, it like set up instantly. Some weird chemical reaction. Like, unless it was really soupy, it was a disaster. It was like it would set up in a minute. I couldn't even use it. But again, you get your refractory bricks, get them nice and wet, carve that channel. I mean, you could use lintels. You could put steel underneath if you don't trust your mortar. That's not a big deal. And not an angle iron. Just, your gap across is so thin, you could just use some steel pieces underneath, which you don't really need to do. The whole point of this design is you don't have a huge gap to bridge. And so I think I'll be fine. And again, if you put any weight on the ends on top, that's going to hold it too. But that ceiling up top, there's nothing on top. So I carved that channel, and I'd like to show you how to do that. And I'll probably this is getting so long, I'll probably just get this loaded, maybe make a follow-up video for all that little minutia and how to work with the tools and how to cut the lintels, and maybe I'll do that separately, but I don't think it'll be part of this video. I probably started using a decent amount of mortar for the fire bricks there because I probably was a little lazy with my base. Wasn't exact. If that base is completely perfectly level, then again, you almost don't even need mortar. Just little tiny thin layer, and you smush it down. You can build your firebox in 2 or 3 or 4 days. It took me like 2 weeks because I had to take half of it apart. It was a disaster. So you make sure your base is completely level, and if as you stagger, you want to use, maybe you forget the refractory mortar because your 1 part clay to 3 parts sand, that's going to fill the gaps. It's going to keep the air from going in and out. And these darn bricks they're cut so perfectly, and they're so heavy. Where's it going to go? I mean, why do you even need refractory mortar? I don't know. It's up to you. Either way, butter them super thin, smush them down, and get your firebox built in 2 or 3 or 4 days, other than 2 or 3 or 4 weeks like me. Thanks for listening and watching.